Because you know I'm all about that bass, no trouble. I'm all about that bass, no trouble. I'm all about that bass, no trouble. I'm all about that bass.
I'm bringing exponents back. Hey, welcome to another episode of This Week with Cheek. Hey, big shout out to Megan Trainer for helping us remember that it's all about that bass. You might be thinking, what is he talking about? Well, when it comes to exponents, it's really important to understand what your bass is. So let's see what we're talking about. So we're going to take a look at the rules of exponents, but first I want to review with you what an exponent is and what a base is. So we're going to take the number 3 and we're going to raise it to the power of 4. 3 is going to represent our base. That's just the number that's being multiplied by itself. The exponent tells us how many times we're going to multiply the base by itself. And so we take 3 to the 4th and we can actually expand that and show exactly how many times we're going to multiply the base by itself. Let's take a look at a few more examples. So we've got 2 different forms that we're going to look at today. I'm going to go back to 3 to the 4th. That's considered exponential form. So anytime you have a base with an exponent, we're going to say that is written in exponential form. And if I ask you to expand, then you're going to actually write out how many times the base is being multiplied by itself. Again, for example, 3 times 3 times 3. One more example. We'll take -5 and raise it to the power of 2. Okay? Expanded form, -5 times -5. So again, we've got 2 different forms, exponential and expanded form. Now, we're going to take a look at some of the rules of exponents. The product of powers rule. So I want you to sort of explore this rule with me. We're going to take 3 to the 2nd, and we want to multiply that by 3 to the 3rd. Okay? And there's a cool rule that really helps us understand our exponents, our powers here. But to see the rule, we need to write this in expanded form. So I'm going to go ahead and write 3 times 3 to represent 3 squared. And then 3 times 3 times 3 to represent 3 cubed, or 3 to the power of 3. And so how many 3's do we have here? 1, 2, 3, 4, 5. So guess what? 3 squared times 3 to the 3rd equals 3 to the 5th. Hey, guess what? If I simply keep the base, thanks Megan Trainer, and add my exponents, that would have given me 5. Let's try another example and see if that works. So we'll take 4 to the power of 3 times 4 to the 5th. Now, if our rule is correct, we should be able to simply keep our base, which is 4, and then add our exponents to get our answer. So I've got 4 times 4 times 4, and then 4 times 4. That's a total of 1, 2, 3, 4, 5, 6, 7, 8. Really cool. So our rule here says if you're multiplying a power times a power, you can simply keep the base and add the exponents. Let's take a look at another rule. Our quotient of power. So quotient means to divide. So if we are dividing one power by another power, okay? So we've got 3 to the 8th divided by 3 to the 5th. Now again, I'm going to go ahead and expand this expression so that you can see it in expanded form. 3 times 3. 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to divide that by 3 to the 5th. So when I'm dividing, a number divided by itself is 1. So a lot of these 3's are going to divide each other out. And that leaves me with 3 3's in the top, or 3 to the 3rd. Now, what I notice here, and what our rule tells us, I could have just kept the base, which is 3, and simply subtracted my exponents, which gives me 3 to the 3rd. Let's take a look at one more example to see if that works. So let's say we've got 2 to the 7th divided by 2 to the 5th. I should be able to keep my base and subtract my exponents to get my answer. If I expand 7 2's, 1, 2, 3, 4, 5, 6, 7, and divide it by 5 2's, these 2's cancel, divide out, divide out, divide out. And there again, I'm left with 2 squared. And if you subtract, keep the base and subtract your exponents, you get 2 squared. So real quick, if we're multiplying 2 powers, we can keep the base and add the exponents. If we're dividing, we can keep the base and subtract the exponents. Hey, there's a lot more rules as we go through these exponent rules that we'll dive into, but I just wanted to get you started with 2 very important ones. Our multiplication, power times a power, and our division or quotient of powers. Thanks again for joining me for another episode of This Week with Cheek.